All right, moving on to part B of question 12. I realized that there wasn't a lot of space in the last one, so I put this on a separate sheet of paper for you guys. Also, this problem, at least for me, or in my opinion, I thought this was the most difficult problem just because of how many different steps that you have to go through. So hopefully I can help clarify some of the big points as we walk through this problem together. All right, so reading the question, we have aluminum chloride reacts with lead 4 nitrate. What we're gonna do is write out that expression and balance the equation to start. The other important thing is we have 18.5 grams of the reactants present. So that's gonna be both the aluminum chloride and then the lead. All right, so let's get to it. We have right up here, we have the expression written out and I also balanced it for us. All right, so that's gonna be really important in this. Looking at the first question, it says to find which reactant limits. To do that, we are going to convert both of the reactants. Both of these two have to get converted to moles. Okay, so you're going to perform these simple calculations, go grams to molar mass to get them into moles. And then you are going to use these moles and use the mole ratio to try and figure out which one is going to be limiting. So looking at the expression in the reactants, you see that there's a 4-to-1 ratio that exists between these two reactants. So for every 4 moles of NH4Cl, there should be 1 mole of PbNO3,4. So because these are much lower numbers, we're gonna have to use a conversion so that we can get these numbers to look more like this to tell which one is limiting. So I'm going to start with this expression right here, the 0.3458 moles of NH4Cl, and I'm going to convert that to 4 so that we would have a better look at the ratio. So that's what I did right here. 4-to-1, I divided by 4, and that means that I had to multiply by 11.567 to get this expression to 4. So theoretically, if I multiplied 11.567 by the moles of lead nitrate, I should also get 1 because that's the ratio, right? That's the law of multiple proportions, right, that we worked on previously. So if I continue to do that, I multiplied this expression and I actually only got 0.4696. So I got about half of what I needed to get. So that did not equal 1, and that tells me that this lead nitrate is the limiting reactant in this step. So that would be my limiting reactant, and that's what I'm going to use for the rest of the expression because I'm never going to have more than this reactant right here. This is going to determine how much is produced, okay? So moving on to the next question. The next question says how many grams of the excess reactant would remain. So there are a few steps that you got to do to get this one. You start with your initial, right? So this is our limiting reactant. So this is going to be the one that we were using for our calculations now. So 18.5 grams of our limiting reactant convert to moles. And now you're going to do the mole ratio to figure out this step. So you go from lead nitrate and now we're going into NH4Cl, okay? And then that, going through that sequence, you were going to get 8.695 grams of NH4Cl being consumed. Okay, so that's how much was consumed with our limiting reactant. So now that we have what's consumed, we'll go back to what we started with. So here over here, we have what we started with was 18.5. 8.695 was consumed. So the remaining, the leftover, we're gonna have 9.805 grams of NH4Cl that is gonna be remaining. So none of this gets used up in the reaction because of what we previously talked about, because this is the limiting reactant. So it's not going to go to completion. So that's why we're going to have extra NH4Cl. Had these ratios been even, we would have consumed all of this reactant. All right. So that is part 2. Now part 3 says how much lead 4 chloride is made. So to do that, now we're still going to use our limiting, right? This is always going to be our expression after we figured it out. It's limiting because we're never going to produce more than our limiting reactant. So we go through the sequence, convert to moles. Now we have moles of our limiting reactant, and then we are going to lead chloride this time. So lead chloride, they have the same mole ratio. So what I did here is really critical because this is how much we actually have. If I wanted this to be a 1, I would have had to figure out how much I would multiply the other side, right? Because what I do to one side, I must do to the other. So conveniently, because both lead nitrate and lead chloride had the same ratio, this works out. However, let's say this had a 2 and this had a 1, I would have had to make this a 2-to-1 ratio. So I could have either put this 2-to-1, or this would be 0.0406 and this would be 0.0812. Okay, so it's very important to make sure that you're putting the right ratio of moles between these two. And then now that you're in moles of lead chloride, you put the molar mass to find the grams, and that gets you 14.2 grams of lead chloride, and that's how much lead chloride is made. All right, and then the final step, now it says if 9.5 grams of lead chloride are experimentally made, what is the percent yield? So here you need a calculation. You're gonna need a formula. So I wrote out the formula right here. It is experimental over theoretical times 100. So it just gave us the experimental value, which is 9.5 grams of lead chloride. You divide by our theoretical, which is what we calculated in the previous question, and then that gets you 66.9% of the yield in this expression, okay? So I know it was a lot. Take a chance to look back through and let me know if you have any questions.